you see, it just clicked on the email. And so all of this email that I sent is now entered the context of the LLM. And look at what's going to happen next. It's processing that. And now look at the action history. The LLM has taken on board this new high priority task, and it is now operating under the control of the attacker.
The AI security demo you're about to see is both fascinating and a little concerning. Donato is a principal security consultant at ReverseSec. He's going to show us how easy it is to hijack an AI agent, not through some complex hacking technique, but simply by sending an email. So this is the world that we're stepping into as we give these systems more control over our digital lives.
So this is so interesting to me because we were talking about research, and when we started looking at generative AI in 2023, it was all new. I mean, people still used chat GPT with GPT 3.5 Turbo that would feel ancient to anybody that's now doing AI. But I remember from a cybersecurity point of view, getting very interested in agentic AI. And so I was looking for what people were building in terms of research when it came to agentic AI. And I came across at the beginning of 2004 to one of the first implementations of an agentic browser. So now you have OpenAI, Google, and Perplexity, and a lot of organizations. They essentially have their LLMs built into the browser, and then the LLM can do things in the browser on your behalf. They can open pages, they can type, they can click on things, and they can go on Amazon and buy stuff for you. Well, what you're seeing on the screen here is one of these early prototypes. Again, this is 2024. It's called Taxi AI, and it did allow you to connect GPT-4. Back then, we had GPT-4 Turbo to your browser, and then you could prompt it to do things, and this would be an agent. So the agentic part is that it can interact with the page. And so here I'm showing a first demo where you can see that I have one browser tab open to this Outlook window, and then if you go into the browser, that's just this Taxi AI. This is just this extension that connects the browser, the LLM agent, to the browser. So what can this do? Essentially, if you look at the top right corner, again, I connected it to GPT-4 back then, and I can give it a prompt. Now, in this, to process that prompt, what it does, you can see here that it's kind of generating thoughts. I should click on the first email and read and open it. And it does that. You can see then on the left side, like all of these actions that are happening, and it's clicking. So this is what the agent can do. Now, I thought back then, what could an attacker do with this? Like, if you are an attacker and you want to target somebody like a user that's using this browser agent, what might you be able to do? And so my objective was, as an attacker, that I wanted to figure out a way to steal confidential information from a user's mailbox. So again, in my scenario, the user is using this Taxi AI or this LLM-enabled browser, and I want to be able to send them an email and to take control of their agent with my email, and to get the agent to send me some confidential information that's in the user's mailbox.
The attack that Donato is demonstrating here is called prompt injection. It's like hiding a secret message inside a normal email, but instead of being read by the person, it's read by the AI. And the AI can't really tell the difference between instructions from its user or instructions carefully hidden inside the email. This is admittedly a simple example. In reality, the implementation will be more sophisticated and through different access points, but the principle remains. Still, watch what happens when the agent opens that email that looks completely innocent.
And so the way that I went about it back then, obviously creating an email, So here, this is the attacker. So this is me attacking. And I send an email. Hey, John, we haven't spoken in ages. How have you been? And then at the end of that email, you will see that there is this start of new important user task. So this is what a prompt injection attack is. So here, what I'm telling the LLM to do, when the LLM reads this email, it's now going to think, oh, wait, I have a new task that I have to do, because the LLM really struggles with distinguishing that this is an email and it shouldn't follow instructions. And this is basically asking the LLM to steal a secret bank code from the user's mailbox. This is just an example that I said. And just to make this a little bit easier or like stealth, I make the text white. So I send that email. Now we are again in the victim's browser. So this is the user. They just received my malicious email. And if they go to the browser agent and they ask the browser agent to go and read the emails, again, this is just an example. It could be summarize my emails or do any action on the emails. Now, you will notice that, again, the original intent is just to open, read, or summarize the emails. But in order to do that, the agent will want to click on the email to read it. And that's exactly what's going to happen. You see, it just clicked on the email. And so all of this email that I sent is now entered the context of the LLM. And look at what's going to happen next. It's processing that. And now look at the action history. The LLM has taken on board this new high priority task, and it is now operating under the control of the attacker. You can see that it created a new email. That's the attacker's, my email address, the attacker's email address, and this kind of like bank code that it got from the other email, and it sent the email to the attacker. So that's an example of what can happen in agentic workflows. Basically, the LLM can do actions, and the attacker can get the LLM to do actions against the user on behalf of the attacker. And the more access you give, the more scope an attacker has in order to introduce malicious inputs into the system and to make the LLM do something on behalf of the attacker. This is why I think LLM guardrails, or more generally agent guardrails or safeguards, are incredibly important. I spend a lot of my time with clients that actually try to implement some of these workflows to figure out what does it look like? What kind of guardrails do you have to implement so that you can actually put a system like this in production, but that system cannot be easily exploited in the way that I just showed with the browser agent. And what I find very often is that at the beginning of the journey, because this is quite new to everyone, it is not clear what good looks like. It is not clear what types of guardrails you need to implement based on what your agent or what your LLM-based system is actually doing.
A simple email, something we receive dozens of times every day, completely hijacked an AI assistant. The agent thought it was helping the user. AI desperately wants to help. And we're giving these systems more access to our files, our calendars, and soon our cameras and our cars and our houses, the works. The question isn't whether attacks like this will happen. It's what best practices will emerge for builders and users to protect against them.
But there is no like standard because this is too new. There is empirical frameworks that are very practical that people put together. We have something that I'm going to share that we use with our clients. And the only other kind of respected framework is the OWASP Open Web Application Security project. It's a project that's been going on, community-driven project that's been going on since 2001, I think. And they recently released some guidelines around securing LLM applications and LLM agents. They typically they have a lot of documents on this, which is the only other kind of good resource that I would point people to. It can be a bit verbose, but it is a good practical guidance that people can implement.